Okay, sorry for that. As you know now, we'll dive into recreating Sonic the Hedgehog's movement in Godot 4. This is going to be part 1 of a series where we'll cover everything from movement mechanics to terrain physics, object logic, and advanced enemy combat. So before we jump into code, I decided to combine the best elements of Sonic's abilities from different games, inspired by titles like Frontiers, Sonic Unleashed, and even classics like Sonic 1. This moveset aims for responsive, comfortable controls tailored for PC keyboards. We got the roll, the stomp, jumping, obviously, but we are going to feature Coyote time, inspired by fast, sliding, bouncing, that spin kick from Sonic 06, spin kick jump from Sonic Adventure 2, air dash, spin dash, drop dash, boost, air boost from Sonic Forces, wall running, and that's it. We'll start by setting up our player character, create a character body 2D node, and add an animated sprite 2D for visuals and a collision shape 2D for hit detection. This structure will serve as Sonic's foundation. Next, we'll implement gravity to simulate Sonic falling to the ground. We'll use a function named gravity with two variables, fall speed and gravity. Adjust these to control how fast Sonic falls and reaches terminal velocity. Then call gravity inside the physics process delta function to apply the effect in every frame. Now, time for movement. Define variables for speed, acceleration, friction, and turn acceleration. Here's how we will adjust Sonic's velocity based on input, and this little snippet ensures smooth starts and stops, giving Sonic a responsive feel. You may have noticed how we are not using that last direction variable we scripted before. This is just to store the direction so we can use it for further skills like the air dash and others. To store our previous direction, we will create a new function that will use two conditions stacked to handle direction storage. Now that these details are ready, let's roll right to the first skill. The rolling mechanic is essential for Sonic's speed-based gameplay. When the player presses down while moving, Sonic enters the spinball state. His momentum is preserved and friction is reduced for faster travel. Notice how we tweak the function value here to make Sonic slow down gradually while rolling, just like in the original games. The stomp move allows Sonic to hold his momentum and hit the ground instantly. The logic is simple, just set horizontal velocity to 0 and vertical velocity to maximum value. Additionally, we add a lock state to permit other actions like jumping or boosting while stomping. Jumping is standard in platformers, but here we add a feature called Coyote time. This gives players a small window to jump right after leaving the ground, making gameplay feel more forgiving. Try adjusting the Coyote time variable to balance between responsiveness and challenge. The slide move lets Sonic navigate tight spaces and dodge obstacles. When sliding, we reduce friction slightly, just like in his spinball state, so Sonic can maintain some of his momentum. This also interacts with our movement logic. Sonic should only slide while on the ground and moving. The bounce skill lets Sonic rebound higher than a standard jump when he hits the ground. It's great for chaining jumps or avoiding hazards. Unlike the stomp, this move does stop momentum but adds upward boost instead. The bounce is triggered mid-air, setting a special state. Once Sonic hits the ground, we reset the state and apply a strong vertical velocity boost. The spin kick is a powerful attack move. When Sonic is stationary or moving, pressing the attack button triggers a spinning kick animation. Now, chaining a spin kick into a jump allows Sonic to transition smoothly into the air, maintaining his flow. This skill is triggered by pressing the jump button during a spin kick. Now, the air dash is a move from Sonic Generations that gives Sonic extra mobility, while airborne, pressing the dash button launches him into the direction he's facing, allowing for precise platforming or last-minute recoveries. Notice how we use a timer to limit the dash duration, ensuring it feels snappy and doesn't overlap with other skills like the boost. Spindash is a classic Sonic move. By holding the button, Sonic charges up and releases stored energy to launch forward. The Dropdash, introduced in Sonic Mania, works similarly but triggers when Sonic lands from a jump. Using the lerp function, we smoothly interpolate Sonic's speed based on the charge time, and for the Dropdash, we tie the release to Sonic's landing logic. The boost move is mapped to the right trigger. On the ground, it provides a burst of speed, while mid-air it also launches Sonic slightly upward. To prevent overlapping input, we add a lock boost state to disable boosting from other skills temporarily. Experiment with different boost speed values to balance control and speed. Wall running adds an exciting dynamic to level design. While boosting towards a wall, Sonic transitions into a wall running state. We adjust velocity to simulate upward movement and lock certain actions to keep the gameplay smooth. Combine these skills with the air boost to change stylish maneuvers. A polished game feels responsive, and small details like flipping the sprite when changing direction makes a big difference. To implement this, we use the horizontal velocity variable to track which way Sonic is moving and adjust the horizontal flip property of the animated sprite 2D. This ensures the sprite always matches Sonic movement. When Sonic approaches an edge, he balances to alert the player that he is close to falling. This is handled using two raycast 2D nodes positioned under Sonic's feet. These will detect whether Sonic is standing fully on the ground or near an edge. This small detail adds personality to Sonic and makes the game more immersive to players. In Sonic games, running into a wall doesn't just stop the character completely, it also triggers a pushing animation, so we replicate this by detecting if Sonic is moving into a solid object and playing the corresponding animation. Finally, animations and sound effects are critical to making Sonic feel alive. For animations, we use the play function on animated sprite 2Ds, triggering specific animations based on Sonic's state. Sound effects are handled similarly using audio stream player 2D nodes to play sounds only once per action. And that's how you bring Sonic's signature style to life in Godot 4. We've covered movement, gravity, and a host of skills, as well as polishing touches like animations and sound effects. In the next video, we'll add level elements and regular terrain, loops, and water. I will be leaving the project in the description below and a playable browser version of the game for you to try out. Thank you so much for watching this video. I really hope it is helpful for your projects, and I'll see you in the next video.